All right, well, thanks a lot. I'm really excited to be here today. I'm going to be talking today about moving fast, and in particular, how you can move fast as an organization, but still have your site perform well, still have your code be fast. These things are often at odds, and doing it well sort of requires a combination of technology in terms of how you set up your code and how you set up your code frameworks, how you measure things, what kind of tools you have, and also a lot about engineering culture. And I'm actually going to probably focus the most on the engineering culture part of this. You've heard a lot about tools, and now I'm going to talk more about sort of the people aspect of this. So moving fast is something that's really important to us at Facebook. As you probably know, we've grown a lot lately. And when people ask how we scale the site, sort of my most general answer to that is we deal with scaling by having an engineering team that's able to move quickly and deal with things as they arise and figure out problems as they come up. If you look at this graph, there is nowhere along that graph where we're like, oh, wow, we got through that. Now I can take a deep breath and think about what's going to happen next. Every week is our biggest day ever. And we obviously know where this is headed, but you can't predict anything. And being successful at this week after week really has to do with having a team that can move quickly, that can deal with problems as they arise. This is also really important to the product. So part of the reason we have all those years is we have a product that people love. And when you're building products, it's not actually the building of the thing that's usually hard. It's figuring out, what's the thing I'm going to build that people are going to like? What's the thing that people are going to use? And the only really good way to figure that out is to try things and see what people do. And the way you try a lot of things is you're able to move fast. So at Facebook, we actually shoot for being able to move as fast as putting changes in every day. Like I had an idea last night. I got it this morning. I coded it up. It's on the site this afternoon. And tomorrow I have data about it. And so if you compare that to even what a lot of people think of as fast release cycle of a couple of weeks, if you get down to making changes every day, you can get done in a month what somebody else could get done in a year. Because every day you can run another experiment, find out how to make this thing better. So in terms of being able to get that fast release cycle, talk a bit, because we're a website, we sort of have very few external requirements. We have a lot of leeway in what we release when. We don't have a big shrink wrap release coming up and a big date when there's partners waiting for things. But we have this one huge requirement that the site can't go down. And so what this leads us to is essentially a culture of making very frequent small changes. So this is great because it allows people to move quickly and iterating on things. It also turns out to be really great for keeping the site running because when you have a problem in production on your site, by far the hardest part of figuring it out is figuring out what caused it to go wrong. Once you know what went wrong, it's usually trivial to fix it. And if you've only changed one thing at a time, it's really easy to figure out what broke the site. And so even when we do major changes, we try to get the deployment to look like this. So if we're launching, say, a new big backend to completely replace a previous one, we'll actually get the new one up running in parallel next to the old one. And first, we pound the new one with traffic, make sure it does what we expect, with fake traffic that's not going to users. And then we very slowly dial the traffic from the old to the new, a few users at a time, and we very carefully watch what's happening. And if there are problems, we can dial it back. So moving fast is great for a lot of things, but it can also get you into trouble. If you're not paying attention to something and you're moving it fast, the thing you're not paying attention to can get bad pretty quickly. And so we had let our site get pretty slow. At the beginning of last year, we were about 5 seconds, 75th percentile time until somebody could interact with one of our pages. We used to joke that our team moves fast, but our code doesn't. And so we undertook a project to make it twice as fast. And we managed to do that. So between June and December of last year, we moved from 5 seconds to 2.5 seconds. There's talk later this afternoon from Jason Sobel and Changhao Zhang about the specific things we did to do that. So I'm not going to cover that in detail today. But what I do want to talk about is a second problem, which is once you've made this fast, how do you keep it fast? There's a really easy way to keep it fast, which is don't change anything. But we're hoping to do better than that. And so what I'm going to talk about is how we manage to change our product quickly, to move fast as an organization, and keep this speed going well. And so the first thing to think about is, what is it that makes the site get slow? So most people, when they think about performance engineering, think of it as sort of this black art where you have a deep understanding of systems and a deep understanding of algorithms, and you make a lot of careful trade-offs, and you play some crazy tricks to go. But and certainly there's performance work that is that, but a lot of things are slow just because nobody's paying attention to them. More code gets slower. You're moving fast, you're adding features, you're adding lots of code. This is, of course, particularly true on the web, where all this code has to be downloaded to the client. And you also introduce things that are basically bugs. You have this complicated system, and when you make changes to it, unintended things happen because it's too complicated to reason about the whole thing. And sometimes those are things that make it slower. So the same way you can't expect a new piece of code to not have any bugs in it, you can't really expect a new piece of code to not have performance problems. So simply put, new code is slow and more code is slow. And this is a problem at Facebook because we were very good at producing lots and lots of new code for all of these great new features. So what did we do? The first thing is basically take the new code and try to age it. So go through and fix all of these small things that had built up as we had been building all this new code. And sort of for keeping things slow, that's anything you particularly care about, you have to allocate some amount of time to building it, and you have just the same way you allocate some amount of time to testing it and shaking out the bugs, you need to allocate time to shaking out the performance problems, which are inevitable. And no amount of analysis beforehand will keep you from having that. The same way you can't avoid having bugs in code you've written by doing analysis. You can't really prevent the performance problems. You just have to run the thing and see what it does. We also did two big systematic projects, two sort of system-wide, sort of more infrastructural projects. And so Jason and Changhao are going to talk about these in detail later today, but I'll talk about a few things that are important here. The first was called BigPipe, which essentially takes the page, breaks it into a lot of small pieces, and pipelines them. So the part of the page that you really care about at the top has shown up before we start working on the stuff at the bottom. And the second one is Primer, which is a JavaScript library that starts by downloading sort of the bare minimum stuff you need to have a page be interactive. And the thing that's interesting about both of these is they share the same property, which is that it separates the code into a fast path and a slow path. And it defaults things into the slow path. This isn't a particularly novel idea in computer science, but it's something that isn't true of sort of the default way most people do web development. Usually I have my new feature.js. It goes and include in kitchensink.js, and it makes everything slower. But these try to keep it separated. So for example, I have a crazy idea for a new feature, and I call it Poke. And I don't know exactly what it does or why somebody would want it, but I'm going to put it there and see. And so when I'm developing this feature, I don't actually have to worry about making it fast, because by the time the user is seeing the part of the page they actually care about, my feature hasn't even started generating on the server yet. And similarly, when you want to mouse over it and have all my the lens flares come up or whatever crazy JavaScript things I'm doing with it, that gets loaded in on demand, or it gets loaded in after the fact. Now, this is great for the site because me trying out this Poke thing doesn't make everything else slower. It's also great for me as a developer that I don't have to spend a lot of time making this thing fast when I don't know if anybody is going to want to use it. And I don't have to spend any time arguing with somebody about whether or not to let me put it on the page, because it's not hurting the experience that we really care about, which is that top of the page pops up for the user immediately. But say Poke does get popular, and all of a sudden everybody's using it, everybody's poking everybody else, and we want to move this way up to the top of the page, and this is going to be important now. So now is this point when we actually do the hard work of performance engineering, where we make those careful trade-offs, where we try to play tricks, essentially figure out how can I implement this in a way that uses only sort of this tight core of fast path code, or if I need to change it, how can I change that in a way that's not destructive? And the important thing is that we're only doing this exactly where we need it, on the feature that's actually popular, that's actually used. And so the next thing is, OK, now that my feature is up at the top of the page and it's important, and people are relying on this being fast, now I have to measure it. It's actually sort of two different classes of measurement tools. They're measurement tools that, given that something is slow, help you figure out how do I make this fast. And so those are a lot of these waterfall tools. This is a picture of our backend tool called PHProf, which is essentially a profiler of all of our PHP code running. And so there's a lot of these tools that are essentially the performance equivalent of a debugger. Is that given something isn't working the way I want it to, help me figure out how to make it better. There's a second class of tools that's often conflated with this, which is the tool that tells you that you have a problem. And so I'm actually not going to talk much more about these tools, but I'm going to talk about the alerting sort of tools because those have a lot to do with culture. And the thing that's interesting about an alerting tool is the granularity at which you alert. So one of the problems when people conflate these is they try to use a tool like this to alert on something. And what we find is that you can write a script that every day looks at this profile and tells me which functions have gone up and down. It turns out that's almost useless information for telling you if you have a problem. Because people are always changing the code. They change the names of things. Time that has to be spent gets moved from one function to another. Actually finding real regressions is like sort of opening up GDB to go look for bugs when you don't know that you have a bug. You can't really pick through the information. On the flip side, you could sort of say, OK, the thing I really care about is that users aren't getting slow pages. So what I'm going to do is have one big graph of the average or the 90th percentile or whatever of all the pages on my site. And if that gets a little bit, if that gets slower, then I know I've got a problem. I'm going to go hunting for it. So I have my poke feature, and say I make it super poke, and now it's way better, but it's slower. And so somebody comes to me and says, hey, the site's 1% slower now because you launched this feature. It's like, do you think I'm going to care? I'm bringing pokes to the world. This is really important stuff. And so, and it's even harder to say it's 0.1%. Do I care about that? That sounds like nothing, but if you do that every day for a year, you've gotten 30% worse. And so, but if instead you come to me and say, your poke feature is 50% slower than it was before you added all these features to it, now I'm going to care. It's like, oh no, now people aren't going to be able to poke each other as well. I don't want my feature to be slow. And so I'm actually going to be, I'm going to have some incentive to go and fix it. So the thing with the tools is that when you're alerting for a problem, you really need that alert to be at the granularity of basically what a single person works on. Because at the end of the day, it will be a person who goes and fixes that thing, and they'll fix it because they care about it. And it also makes it easier to reason about. If, really, who can answer the question, is this feature worth 1% slower on everything? That's a very hard question to reason about. But this part of the page just got 50% slower because we added all these features to it. Now it's something I can actually make a reasonable local decision about. So I'll talk about a couple more sort of the last thing I'm going to talk about is sort of how we structure our organization to sort of deal with performance problems as they arise. I have kind of two basic principles. The first is that nobody's going to do anything unless they care about it, which is completely obvious but very important. The second is that if somebody is responsible for something, they have to have control over it. This is also one that sounds pretty obvious, but people violate this rule all the time. In almost any situation where people are really frustrated over their job is because they're responsible for something that they can't control. The classic example of this is somebody who has to deploy code that somebody else wrote. When they deploy it and the site breaks, they feel responsible, but the person who wrote the code and wrote the bug is actually the one who had control over whether or not the site was going to break. And so getting these two things to work, so in the context of our performance team, we've tried a whole bunch of different models on how to do this. is to sort of run the spectrum. On one end is a centralized team where you basically say, we're going to have a few people who are going to make the site fast. We're going to take 3 or 4 people, and that's going to be their job. And this does great on the people caring about a test, because these people, they're going to wake up in the morning wondering, how am I going to make Facebook faster? But it fails the control and responsibility test, because most of what causes a site to be fast and slow is all the application code being written by product teams every day. So this team becomes frustrated. They either feel like they're fixing everybody in the world's bugs, or they feel like their job is to tell everybody not to change things because that's the only way they're going to get what they need. I guess that's another thing about sort of when you separate responsibility for control. Often if I'm responsible for something I can't control, the only control I do have left is just to tell people not to do something. So it essentially creates somebody whose incentive is just to say no to things, which is really bad. On the flip side, you can say, OK, every product team is going to be responsible for the performance of their product. And this is great in terms of putting responsibility where it needs to be, but it's not great in terms of people caring about it. A few people are going to care about it, but you can't get everybody to care about the performance. And even the people who do care, if their primary goal is launching their product, they're not going to feel that great about this. So we've tried to adopt a model in the middle, where we essentially have a centralized team, but it's not this team's job to go and fix everything. It's this team's job to build tools, to do analysis, to work with the product teams to help them do well. And then on each of the product teams, we take one person and appoint them as a performance point person. And so this is a person who still works on a product team. So they still have ties to that team. They still have control over what's going on in that team. They know what changes are going on. But then they're also tied into the centralized team, which wakes up every day thinking, how are we going to make this faster? And they can worry about sort of overall strategy, figure out what are the really important things. And then when there is a problem, they go talk to the performance point person on the team and help them work through it. And that person, over time, learns how to deal with performance in the context of what their product team does. And we found this to be much more successful than either of the other sort of extremes of organization. So I guess to sum up, so the 3 most important things to take away. The first is fairly obvious, but I think it's often overlooked, that new code is slow, that you can't really expect. We used to think, OK, well, we're going to try to build tools that are going to catch every performance regression before it goes out. And you can't really do that. You launch code all the time. You make changes. From time to time, you're going to make things slower. And you just got to expect that, and you've got to be ready to deal with it. Whenever possible, you should do that so developers can try these things and build this new code in a way that doesn't actually affect the things you really care about, which is the top of your important pages popping up fast. And the last thing is that you should never set up your organization so that there are people whose job is to say no. And that's sort of the worst thing for being able to move fast as an organization, is have people whose incentive is to just slow things down. And yeah, so thanks a lot.